Hi, I'm Gayle Laakmann McDowell, author of Cracking the Coding Interview. Today I want to talk about the contacts problem. So in this problem, we're asked to implement a very simple contact list. And the contacts list will need to be do two things. It will need to, first of all, add things to it, but then it will need to, given a string, figure out how many contacts start with that string. So of course, one way we could do this is we could just store this in a giant list or something like that, maybe a sorted list, and walk through, and for any given string, just walk through that whole list and see, ask each string, do you start with this substring? Do you start with this? Do you start with it? But that'll get pretty inefficient. This is the kind of problem, though, that a trie is perfect for. So all we need to do, essentially, is just build a trie for ourselves. So store all of these people into a trie, and then when we get a string, just walk through that trie walk through that trie with that substring, and then we get to that substring, say, okay, how many children do you have? So that's the basic implementation, and that's what we have to do. Now, one little optimization is, one thing we could do is when we get some substring, find that node and then walk through all of its children and count how many there are. But even easier, actually, is just let each node in the trie actually store how many children it has. It's just, that's actually a very easy thing to keep track of as we go, and it'll make our code actually a lot more efficient. Also shorter to write, as it turns out. So we'll go ahead and take that approach. So I've already started us off here with the basic outline of how the trie will work. I've just created a node class. I don't need, right, for this problem, an overall trie class. So I've just created a node class, and it will store each child. And by the way, in this problem, we only have the characters A to Z lowercase. It's very simple. So what I've done is I've created a simple array that has 26 slots for each possible letter. Of course, if there is no next contact that starts with that letter, then it's going to be null. You could also, if you wanted to, use a hash map instead. And that actually has some benefits. It takes up more memory, but it's more flexible if you need to change certain things about it. So if you found this problem really overwhelming, here's a good place to stop and retype this code yourself. And now that I've outlined the basic stuff, see if you can get the rest of it. But I'll go ahead and start writing this. So get node is going to need to it's going to just get the node that's at that value. So one function that I bet will be useful for me, and this can actually be static, is given a character, return the index in that array, because I think both getting and setting will need that. So that's going to be done. It's actually very simple. It can actually just be done like this, but it'll be a little bit easier for me to do it that way. Now, get node is just going to return children of the char index. And for set node, not too dissimilar, get the char index of C and set that equal to node. All right, so what add will do, add is our next function. What add will do, and we can actually add this, give ourselves a little initial method, but what add will do is we'll walk through recursively, and it'll pull off each character of an S walking through it, and then once we get to the end of S, it'll insert a node there, or it'll insert nodes as we go along as necessary. So, and again, we're going to start off with the very first character of S. So if I'm at the end, if index is at the end of S, then I'm done, nothing to do. Otherwise, pull off the current character of S, char at of index, and then I'll call this char code actually. And then I'll do get char index here of current. Spelled that wrong. Okay. Now I'm going to say, hey, check if this even exists. So check if there is a child for this character. So I'm going to do get node of char code. Actually, I guess I can just call current here. Now, if child is null, then I need to create that child. So if so, then set node of current, comma, new node. And actually, I want to get the value here. So child is going to be new node, child, and then go and recurse. Call child.add of s, comma, index plus 1. Now one other thing I have to do here is I have to track how many characters, I need to know how many there are. And let me hold off on that and go down to this find method. Now let's turn to how find count works. So what find count is going to do is it's going to also operate recursively, and it's going to walk through the nodes for each character of S, traversing this tree for each character of S. And then if there's no next child with the right character, then I return 0 because that substring actually can't be found. Or if I get to the end of S, then I return the current count. So this is going to require me to actually keep the current count in each node. So I need to have this size variable here. So I'm going to keep the size of each node. Now what's going to happen is every single time I call add on a string actually gets added beneath that. So every single time add gets called, I just have to increment the size. Then on this find count, what I say is if I'm at the end of S, then return the size. Otherwise, go to my next node. So I have to first of all get my next node. So node that equals get node of s.char@. Of index. If the child is null, return 0, because there's actually nothing with that substring then. Otherwise, recurse and do find count of x, comma, index plus 1. Okay, so that's how I implement this. Now let's run this and see how we did. All right, it's looking good. So this is a really, really simplistic implementation of a trie. We could, if we wanted to, do a hash map instead of a simple character array. But for this problem, because of the simplicity of it, a character array is sufficient. So it just seems like this really overwhelming thing to, oh my God, I have to implement a trie. But ultimately, it's really not that bad. Just think very clearly, what does implementing a trie really mean? In this case, it just means we need to have these adds method, this find count, and we need to do some basic getting setting operations. It's really not that bad in the end. So keep tries in mind as a really, really useful data structure. For interview questions, what I've seen is a lot of times when you see a problem where that's framed at where there's some sort of validation against some other input, that's where you'd often end up using a trie. So keep that in mind as you do future problems. Good luck.